In this video, we are going to discuss divisibility tests. And our objective when we're working with divisibility tests is to figure out if a small number will divide evenly into a whole number. That is, can the small one go into the big one with no remainder, no extra leftovers at all? When we do this, we do not want to actually do the division. Actually dividing is an entirely different skill. All we're trying to answer is, will it go in perfectly, yes or no? But we're not going to do long division to get that answer. Now, before we go on, make sure you understand what divisible means. Divisible, and trying to figure out a good color here. It quite informally means it will divide in perfectly with no remainder. And so when we are using a divisibility test, we are checking if divisibility exists, yes or no. Just to reiterate, a number is divisible by another if the second number fits perfectly inside the first one without any remainder. For example, 20 is divisible by 4. If we take 20 divided by 4, we will not get a remainder. If we take 35 divided by 5, we do not get a remainder. You'll notice how I'm not going through and saying here's what the number is, because we're not actually doing the long division here. 22 is not divisible by 6. If you try to take 22 divided by 6, there's a remainder left over. 100 divided by 3 will have a remainder. And so it's not divisible. If we wanted to be able to assess these pieces directly using long division, we'd wind up having to take 100 divided by 3, get 3, multiply, get 1, drop it down to get 10, which goes in 3, which gives us 9, leaving us with a remainder of 1. There's the long way. Actually dividing it out is more work than we want to do. And so our focus here is how do we determine yes or no without having to do this long division in the yellow. And that's exactly where divisibility tests come into play. Now we have two different options. If you want to determine divisibility, you could do long division. You could actually go through and take 520 divided by 4, work the entire thing out, and then see, did you get a remainder, yes or no? That will get you the correct answer. It is more work than we want to do. Or we could use a divisibility test. A divisibility test is a shortcut. It's a way of figuring out if that remainder is 0 faster than the long division. And so we're going to go through and answer questions like, is 147 divisible by 3? And we will answer, is 524 divisible by 4? We're searching for answers with these pieces. And to do that, we need our divisibility rules. Addressing our first problem, is 147 divisible by 3? 3 has one of the trickier rules to work with. In order to check this divisibility, you have to take the numbers 1, 4, 7. You take all the digits from your number and you add them together. What is 1 plus 4 plus 7?
It's 12.
That's a total of 12.
I did not know you can do that.
If you take 12 and divide it out by 3, will 3 fit perfectly inside 4, yes or no?
Yes.
Yes. We don't even need to know how many times it fits in. We just need to know, does it fit in, yes or no?
Yes.
Because the answer here is yes, it's going to connect back up to the top. Yes. 3 will fit perfectly inside 147. And we don't need to do the long division to know that's true. This little process tells us, and it guarantees it. That's our divisibility rule for 3. Add up the numbers, then see if 3 fits inside the sum. That's actually one of the hardest rules to work with. 4 is even simpler.
Add 5.
Please note, this is not saying divisible by 3. A different number is going to have a different rule. The rule for 4 is, instead of looking at all of them, look at only the last 2 numbers. Nothing else matters. Will 24 divide out by 4 perfectly? Yes or no? And we don't even care. We don't want to know how many times. We don't care about that. Will it fit in? Yes or no? Yes. Because the answer here is yes, it connects back up to the top. Yes. 524 divided by 4 will have no remainder. So 524 is divisible by 4. And this stuff in the red is our work that proves that we're right. What about 243? Our rule for 9 is similar to the rule for 3, where we have to add the numbers up. What is 2 plus 4 plus 3?
9.
That's 9. Taking that result, if we divide out by the 9, will it fit perfectly? Yes, it will. So it connects back up to the top again. 243 divided by 9 will fit perfectly. Our work in the red is what proves it. Now, we can use these divisibility rules in other contexts, such as this division. Does this x have to be a whole number? Well, the stuff that I'm going to put down in red is some kind of background information. We know that the area of a rectangle equals base multiplied by height. It's also the same formula for the area of a parallelogram. And so that would tell us that the height is the area divided by the base. We want to know, is this height a whole number? And the only way the height can be a whole number is if the area divided by the base fits perfectly. If there's a remainder, then it's not a whole number. So, this is, based on its context, asking us, is 87 divisible by 5? And so we, of course, have to then use the divisibility rule for 5. That rule is fairly simple. We're looking at only the last number. Nothing else is important. If the last number is 0 or 5, our answer is yes. Anything else, then it's a no. Obviously, ours is 7, so it's a no. Overall, we know that x is not a whole number because 87 is not divisible by 5. Our directions are not asking us to figure out what number x actually is. Right now, we don't care about that. We just want to know, yes or no, does it fit perfectly? That's all. Okay, we can also use divisibility tests in the context of word problems. There are 15 students in your class. Can you divide 840 candies evenly so that everybody in the class gets the same number of candies? There's a typo there. It's supposed to be candies. I don't know why it says something else. So yes or no? This is asking us 840 divided by 15. Will it fit perfectly, yes or no?
Yes.
And we have not yet checked the rule for 6. The rule for 6 is somewhat special because 6 is equal to 2 times 3. 6 actually has 2 rules. The rule for 2 has to work, and the rule for 3 has to work. If we are trying to divide out by 6, as your notes that I gave you indicate, if we're using the divisibility rule for 6, we have to check that 2 works, we have to check that 3 works. If either one of them would be a no, then 6 would be a no. 15 is the same type of problem. Because 15 is equal to 3 times 5, we have to check both rules. We have to check the rule for 3, and we have to check the rule for 5. So does the rule for 3 work? 8 plus 4 plus 0, that's 12. 12 divided by 3 will go in evenly, so 3 is a yes. That's not enough though. We also have to check the rule for 5. It needs to end in a 0 or a 5. Does it? Yes. Because both rules work. 3 works and 5 works. That's what guarantees us 15 works. 15 will divide into 840 perfectly with no remainder. We don't know what it will be if we get the division, but we know that it will not have a remainder. Test.